5, 4, 3, 2, 1.
After this iconic bomb blast on July 16, 1945, many questions arose, like, how did America create the history? And why was the nuclear bomb made? In the year 1789, German scientist Martin Klaproth discovered a dense metallic element called uranium. But still, the journey to become a nuclear weapon began in the year 1896, when a French chemist, Henri Becquerel, discovered the radioactivity of uranium. Then in the year 1898, Pierre and Marie Curie discovered that when an element was being attacked with high energy, it was breaking down into smaller elements. That is, every metal was breaking into small atoms because everything present on this earth is a group of small atoms. So the discovery of radioactivity in elements in Marie Curie's research changed the nature of nuclear science forever, and later on the basis of this research, British physicist Ernest Rutherford prepared a model of the atom in the year 1911, in which the model he developed a complete understanding of atoms, because till now the world thought that everything was made of atoms, but Rutherford proved that these atoms are also made of small atoms like alpha or beta, and according to this model based on this, L.C. Wells described a variety of weapons within the 1914 novel The Word Set Free, which were to become reality in the coming days. Although Dalton is considered the father of atomic theory and weapon, after that in 1932, James Chadwick discovered neutron, after which we had reached very close to making nuclear weapons. So till now different scientists from all over the world were knowing about nuclear energy so that electricity can be generated from nuclear energy. But after this the situation in the world became such that instead of making electricity, man was forced to make nuclear weapons. In the year 1933, in Germany, anti-Semitism was increasing in many countries of Europe. Because of this, most of the Jewish scientists of Europe left Europe and started taking refuge in Britain and America. In 1933, the Italian scientist Enrico Fermi bombarded uranium with neutrons. After this incident, Enrico Fermi hypothesized that by bombarding uranium with neutrons, a bomb could be made that would produce a huge fire. But even before Enrico Fermi worked on this, Benito Mussolini came to power in Italy and became the dictator of Italy, who was very close to Hitler. Mussolini started torturing the Jewish people in Italy because Enrico Fermi's wife was of Jewish religion. For this reason Enrico Fermi left Italy to save his wife, and both of them fled to America, because of which he could not do much research on uranium. German scientists Otto Hahn and Mrs. Lise Meitner, both of whom were working on nuclear physics in Germany for the last 30 years. Otto Hahn bombarded uranium with neutrons and he saw that it released a huge amount of energy. Means Otto Hahn succeeded in breaking the atom in true sense. So in the year 1938, German scientist Otto Hahn discovered nuclear fission. Now by the time 1938 came, atrocities on Jewish people were increasing in Germany. Because of this, Lise Meitner was also a Jewish scientist. So because of this he also had to leave Germany and run away. This is Danish scientist Niels Bohr. He helped to get Lise Meitner out of Germany and he took her with him to his country Denmark. Now the funny thing is that Lise Meitner knew how Otto Hahn discovered nuclear fission. So after going to Denmark, Lise Meitner tells Niels Bohr the secret of what nuclear fission is, how it works and how terrible energy comes out of it. Lise Meitner told Niels Bohr everything. On the other hand, some German scientists started trying to make an atomic bomb in 1939, and the name of this project was Uranium Club, which started in 1939 and its leader was Werner Heisenberg. Hitler's Germany was ahead of the rest of the world in nuclear physics. For this reason, as soon as the news started spreading that Germany is trying to make an atomic bomb, scientists from all over the world became alert that if an atomic bomb came in Hitler's hands, then do not know how he would use it? Now the German scientist Otto Hahn and Lise Meitner, who worked with him, had fled from Germany and told the secret of nuclear physics to Niels Bohr of Denmark, and in the same year Niels Bohr moved from Denmark to America, where he met Enrico Fermi, who came to America first to save his Jewish wife had just come. In addition, there were other Jewish scientists from Europe who fled to America, like Leo Szilard. Therefore, Niels Bohr warned all these experts that Germany was developing a bomb that could destroy an entire city in one stroke. For this reason, three Hungarian-born scientists, Leo Szilard, Eugene Wigner and Edward Taylor, all three decided that if we tell the American government about Germany's atomic bomb project, the American government will not even believe us. For this reason, we will try to talk to the world's great scientist Albert Einstein and send a letter to the American president. Scientists explained to Einstein that Germany was going to build an atomic bomb. After which Einstein also felt threatened by this, because Einstein was Jewish and lived in Germany, who had fled from Germany to America due to the fear of Hitler. For this reason, Einstein signed this letter. Then America slowly started working on nuclear weapons on Einstein's insistence, and American President Roosevelt formed the Uranium Committee. All of them were members of this committee, so they were assigned the task of collecting uranium from all over the world. But only $6,000 was given to this committee. Now uranium was most important for making atomic bomb, and in that era uranium was a rare mineral which was very difficult to get. The world's best uranium was found in Congo, however, was then a Belgian slave. For this reason Edgar Sengier was a government official of Belgium, who was the director of Shinkalabwe mine in Congo. At that time the world's highest quality uranium was produced in this mine. Edgar Sengier became aware of the possible use of uranium in the atomic bomb, so due to this fear, Edgar Sengier sent 1,250 tons of uranium stock of this mine to the New York City warehouse of America. On the other hand, Britain also feared that if Germany would capture the whole of Europe, then later he would attack Britain as well. For this reason Britain and Canada together started the Tube Alloys project, in which UK and Canadian scientists were assigned the task of making atomic bombs. Meanwhile, some intellectuals in Japan had also formed a committee to make an atomic bomb, but the Japanese rulers did not help this committee in any way, due to which Japan was unsuccessful in making an atomic bomb. In the same period, some scientists of USSR were also working on this. So in this way many countries of the world had entered the race of making atomic bombs. Then there was a big upheaval in the Second World War. Japan launched a major attack on Pearl Harbor, an American military base. Now this attack was so big that after this America also got involved in this war. For this reason, President Roosevelt took the need of making an atomic bomb seriously for the first time, and he, along with American scientists and those who came to America as European scientists refugees, ordered all of them to make atomic bombs. After which America immediately bought 1,250 tons of uranium brought from Congo, which was kept in a basement in New York, and America started experiments to make atomic bombs by different scientists at some 30 different sites. After this, on August 13, 1942, America started the Manhattan Project, whose command was handed over to American Army General Leslie Gross. Scientists like Enrico Fermi, Edward Teller, Leo Szilard, Robert Oppenheimer participated. Robert Oppenheimer was made the leader of the Manhattan Project. Why? Because Oppenheimer was an expert in nuclear physics. He had done a lot of research in this field and was also an American citizen. Need a secluded place away from the city for the Manhattan Project. So Los Alamos was chosen for this, because this place would be perfect for this project. The site was built between forests and mountains, and this site was named Project Y. On September 2, 1942, Enrico Fermi successfully discovered a nuclear chain reaction for the first time in the basement under the University of Chicago football field. Because after this incident, it was now certain to become an atomic bomb, and with this incident the nuclear age started on the Earth. Now what is this nuclear chain reaction? When an atom is attacked by a neutron, the atom disintegrates. Then this broken atom is also attacked by neutrons, then again it breaks into smaller atoms, and it keeps on breaking until energy comes out of it. In 1943, Nazi Germany began large-scale bombing of British cities, which threatened the British nuclear project Tube Alloys. For this reason Britain and America signed the Quebec Agreement in the year 1943. So under this agreement, all the scientists of Tube Alloys project running in Britain and their team should be sent to America due to German bombing, and they should be sent to Manhattan in America, be made part of the project. That is, now America, Britain and Canada, all three started working together on the Manhattan Project, and the great intellectuals of that time gathered together on one platform, out of which 12 scientists were Nobel Prize winners. So you can guess yourself how strong this team will be? Because they had detected fissile uranium and non-fissile uranium. Uranium-238 is not fissionable, it does not cause a chain reaction, nor can a bomb be made from it. The simplest way to make an atomic bomb is to get enough fissile material close together that it can cause a runaway chain reaction. It was very important to extract uranium-235. Only uranium-235 can undergo chain reaction. The initial plan was to try out 4 different methods, by which uranium-238 to 235 can be made. In this, first gaseous diffusion, second centrifugation, third electromagnetic separation, and fourth liquid thermal diffusion. After testing out these 4 different technologies, 2 technologies were successful to some extent. First, electromagnetic separation, and second, gaseous diffusion. In electromagnetic separation, a large magnet is used in order to separate uranium-235 from uranium-238. In gaseous diffusion, uranium hexafluoride gas is drawn through a porous barrier, leaving molecules of U-235 behind. But the molecules of U-238 are too heavy, so they get filtered out. In calculations of the critical mass is the minimum amount of mass needed to cause a chain reaction. What is the minimum amount that we have to use these radioactive elements so that chain reaction can take place and a bomb can explode? It sounds easy these days, but it was not so easy at that time. We hardly knew anything about the properties of uranium-235. Uranium-239 was actually discovered only in the year 1940, and by the end of the year 1943 only 2 milligrams of plutonium could be produced. That's why America was developing 2 atom bombs. The first bomb, which was based on uranium-235, which was named Little Boy, was the mechanism of this bomb. Basically it was a gun-type design, in which 2 masses of uranium-235 are taken, which is subcritical, which is less than the critical value, and they are fired on each other to combine faster. With this combination, the critical mass is reached and a fission chain reaction is observed, which leads to an explosion. The second bomb was the plutonium bomb, which was using plutonium-239, and its name was Fat Man. There were difficulties in its designing. Masses of plutonium were kept under high pressure and density. A subcritical mass of plutonium was placed inside a hollow sphere and explosives were used outside the sphere, so that an implosion could be seen. When the explosives from outside explode from the mass of plutonium, there would be high pressure on the plutonium and the critical mass would have reached. This concept was named the implosion method. Scientists already knew about the gun method now, but during this time the implosion method was discovered for the first time. Physicists Enrico Fermi at the University of Chicago built Pile 1, the world's first artificial nuclear reactor. It contained 45 tons of uranium and uranium oxides and 330 tons of graphite blocks. It generated about half a watt of power, and if you can build a nuclear power plant, you can build a bomb. The only real difference between the two is how many neutrons hit the next atom, causing it to split and release more neutrons. If it is less than 1, the reaction will stop, and if it is greater than 1, the reaction will go on. So the scientists at Los Alamos continued to work diligently, night and day, and some 100,000 people were working across the site. On the other hand, on April 12, 1945, U.S. President Roosevelt died, after which Vice President Truman became the 33rd President of America. Truman did not know much about the Manhattan Project at that time, but he was soon briefed on the development of the atomic bomb, and in June 1945, about a month after Germany's surrender, the United States had made its first atomic bomb. Leslie Gross wanted to use this atomic bomb on Japan, because America and Japan were fighting each other in the Pacific Ocean. But no one had seen the explosion of the atomic bomb till date. For this reason, Oppenheimer felt that at least one test should be done. Now initially Leslie Gross refused because plutonium was expensive and rare, but later Leslie Gross trusted Oppenheimer and gave approval to conduct a test. So the bomb that was to be used in this test, it was named Trinity by Oppenheimer. It is a religious term which means a group of 3 things, which was made in the lab of Los Alamos. Its code name was Gadget, which was to be tested in the desert of Alamogordo. On this it was to be tested on a 100-feet tower. You can see in this picture. So the date of July 16, 1945 was fixed for this test. So in the morning, all the scientists of the Manhattan Project, several soldiers of the American Army and some technicians, wearing different glasses, sat 9 kilometers from the test site to see the beginning of the nuclear age. The Trinity test was scheduled for 4 a.m., but was delayed due to a storm. So at 5:29 and 21 seconds, the world's first atomic bomb was detonated. The high explosive squeezes the plutonium core inward. The shockwave mixed the beryllium and polonium, creating a deluge of neutrons. It jump-started a nuclear reaction and there was no way to stop it now. Only 6 kilograms of plutonium produced an explosion equivalent to about 25,000 tons of TNT. The mountains of New Mexico were brighter than the day. The tremors of the earthquake were felt from a distance of 160 kilometers. The mushroom cloud rose up to 12 kilometers in the sky. It was so hot that the desert sand melted into the glassy mineral now known as trinitite. It was a matter of honor that the fire did not flare up in the atmosphere due to the explosion. Creating the first nuclear bomb posed immense challenges. One of the main hurdles was the scarcity of enriched uranium and plutonium, both crucial for nuclear fission. The complex process of enriching these materials demanded state-of-the-art facilities and substantial resources. The Manhattan Project's cost reached approximately $2 billion, making it one of the most expensive scientific endeavors of its time.